Assume that when adults with smartphones are randomly selected, 59% use them in meetings or classes. If 6 adult smartphone users are randomly selected, find the probability that at least 3 of them use their smartphones in meetings or classes. First, we need to realize that this question involves the binomial probability distribution. It fits the parameters of a binomial probability because there is a constant fit. That is to say, there are a fixed number of trials. In this case, 6 adult smartphone users are randomly selected. There's an independence, in other words, the probability that one smartphone user uses their smartphones in meetings or classes does not affect the probability that another adult will also use their smartphones in meetings or classes. There are 2 possible outcomes. They either use their smartphone or they don't. And there's a constant probability, that is, there's a 59% likelihood that any one of them would use their smartphone in meetings or classes. I'm going to use the TI-84 to explain the probabilities involved in this problem. What you see before you is a graph of this particular binomial probability distribution. The way that this is set up, and using the trace key, the first bar that you see here is almost non-existent, but this represents the probability that if you were to randomly select 6 adult smartphone users, that none of them would use their smartphones in meetings or classes. The next bar, where you see the minimum is 1 and the maximum is less than 2, so this is the bar that represents the probability that if you randomly select 6 adult smartphone users, that one of them will use their smartphones in meetings or classes. The next bar represents the likelihood, and here we see that probability given as a decimal, that 2 of the 6 randomly selected would use their smartphones in meetings or classes, and so forth. 3, and the probability given here, 4, 5, 6, and of course, since there are only 6, the probability that 7 would use their smartphones is 0 because there aren't 7 people. We want to know what is the probability that at least 3 of them use their smartphones. So that will be coming to the bar representing 3, the probability that 3 or 4, adding the probabilities, or 5 or 6 of the 6 people selected use their smartphones in meetings or classes. So what we want to do is add up the probabilities that you see here from 3, 4, 5, and 6. And there's a function that will add those probabilities. It's called the binomial cumulative density function. The problem is that that function, the binomial CDF, only starts at 0, but we want to start at 3. So one way to kind of trick the calculator into doing what we want is to say we'll take the total of all the probabilities, which we know is going to be 1, because this is a probability distribution, and we know that the sum of all the probabilities has to equal 1, and subtract off the probability that none, 0, of the adults use their smartphones in meetings or classes, or 1 or 2. And if we take 1 and subtract off the probabilities of 0, 1, or 2, that will leave us with the probability of 3, 4, 5, or 6. So that's the plan. we're going to take 1 and subtract off the probability of everything from 0 up to 2, leaving us with 3, 4, 5, or 6. So to go to the home screen and do that, we'll go to second function quit. And I'll start this by saying we're going to take 1 and we're going to subtract the binomial cumulative density function, and that's found under the second distribution button, which is over the varies button. If you go to the letter B, the binomial cumulative density function, and select it, we're asked how many trials are there. Well, we have 6 adult smartphone users that are being randomly selected. The probability that any one of them use their cell phone is 59%, which we'll write as a decimal 0.59. And now we want to subtract off everything up to and including 2, leaving us with 3, 4, 5, or 6. So the x value here will be the number 2. And when we select paste, this goes into the binomial cumulative density function. The entire line reads as follows. So 1, 100%, or 1, minus the binomial cumulative density function for 6 possible outcomes with a constant probability of 0.59, and we're going to subtract off everything up to and including 2. And when we do that, we have the 0.8066, and they ask this to be rounded to 4 decimal places, so we'll put in 0.8066 and hit enter, and we'll then check our answer, and of course it is correct. So this is another way of doing the problem that you see here in the Chapter 5 homework, problems dealing with the binomial cumulative density function and using the calculator when you have specifically a problem where you're asked the probability of at least a certain number of, in this case, smartphone users who use their smartphones in meetings or classes.